Hello dear students, welcome to Easy Notes. Today we'll start the chapter 5, that is refraction through a lens. Okay, in which we'll be studying about lens and refraction of light through lens. There is nothing but a part A of this chapter. So let us see what is lens. What is lens? Lens is a transparent refracting medium bounded by either the two spherical surface, or one surface is spherical and the other surface is plane. It can be two spherical surfaces, or one might be plane, the other might be spherical. Like that it can be present. That is nothing but a lens. A plane surface can be treated as a spherical surface of infinite radius of curvature. The radius of curvature of plane surface will be infinite, but the radius of curvature of spherical surface will be something r, depending on that surface. Okay, like we studied in a spherical mirror, right? This was a spherical mirror. Two mirrors together like this makes a lens, right? Like that, this will be r1 and this will be r2. Those will be their refractive radius of curvature. And it can be like this as well. One is spherical and one is plane. So the plane radius will be infinity. Infinity of the plane radius of the plane surface will be infinity. This is what they have told here. Okay, next, types of lens. We have two lenses: converging or convex lens and diverging or concave lens. Okay, let's see what is converging or convex lens. Why does it called as a converging lens? Let's see that. So convex lens is a thick in its middle and thin at its periphery. See, thick in middle but thin at its periphery. Okay, in other words, a lens which bulges out in the middle is convex. Okay, it will bulge out in the middle. A light beam converges on passing through such lens, so it is called as a converging lens. Whenever a light beam passes through here, it goes and converge here. Okay, that's why it's known as converging lens. It will converge the parallel beam of light. Okay, now if both the sides are spherical, this type of lens is known as biconvex lens. Biconvex, both the sides are outside, bulged outside. This is known as biconvex. If one side is bulged outside but one side is plane, this type of lens is known as plano-convex. Plano-convex. Okay, if one side is bulged out, the other side is bulged in, so it will be known as concavo-convex. This is convex. Okay, this side is convex, convex, convex. If the other side is bulged out, it is also convex. So convex plus convex, biconvex. If the other side is plane, plano-convex. If the other side is concave, concavo-convex. Okay, similarly, it was like a diverging or concave lens. Why is it called diverging lens or concave lens? Let us see. A concave lens is a thick at its periphery. Periphery means at the ends it is thick and thin at the middle. In other words, we can say that a lens which is bent inwards in the middle is called concave lens. Such lens diverges the light rays incident on it. Whenever the light rays falls on it, it diverges like this. That's why it's called as diverging lens. It's called as diverging lens. See, again, if it is inward, it is known as concave, right? So biconcave, plano-concave, convexo-concave. See, convexo means outward bulged. It is inward bulged. Right, bulged in, it is bulged out. Bulged out means convex. So convexo-concave, convexo-concave. These are the three types of concave lens. These were the three types of convex lens. These will be three types of concave lens. Okay. Next, action of lens as a set of prism. By using prisms, how can we create a lens? See, the lens can be considered as being made up of a rectangular slab at the center and one prism on either side of it. See, there is a rectangular slab at the center and there are two prisms, one here and one here. Either side of this rectangular slab there will be prisms. So this can create a convex lens. And here see, this is also a prism, right? Like this, just kept like this. Okay, this is also concave lens. So we can create a lens by using a rectangular slab and two thin prisms. Okay. Now, what happens? Convergent action of a convex lens. Convergent action of convex lens. The prism in the upper part of convex lens bend the incident. Let us see here. We have three things, right? Okay, we'll see in the next page. Wait. Okay. Clone. Flip. And then we take it as a rectangle. Okay. Okay. Now see, this is a convex lens. Okay. Now what happens? Whenever a ray of light comes here, what happens? This is normal, right? So it will bend towards normal. It means it will bend towards base like this, towards normal, right? Okay. Now this is the normal. Now it will bend away from normal, from denser to rarer. So it will bend like this. Okay. If it's passed through rectangular slab, it will pass undeviated, right? Because it is a rectangular slab, it will pass undeviated. Okay. Next, if it pass through here, this is normal. It will bend towards normal. Now this will be normal, and it will bend away from the normal like this. See here, these rays are coming and converging at this point, right? So this is the converging nature of convex lens. See here, the prism in the upper part of the convex lens bend the incident ray downwards, while the prism in the lower part of convex lens bends the incident ray upwards. See here, let us consider this ray as A, this is B, and this is C. See, this is bending downward, this is bending upward. So the central part, which is parallel side glass slab, passes the ray B normally incident on it, that is undeviated. It will pass undeviated, but these two rays will bend. It will bend downward, it will bend upward. So they can converge at a single point known as converging lens, and that point will be known as focus, principal focus. We'll study later. Okay. Next, if we talk about divergent action of concave lens, see here itself. Wait. Okay. Let's take some shapes. Okay. We'll ball it out like this, right? We'll keep it like this only. Okay, I'll do it like this. Wait, I'll show you in a good way. Let's keep it like this. Okay, clone and flip. These are the prisms. Okay, these two prisms, it is kept behind. Okay, it's kept in such a way that it will cover like this. See, and this way it will cover like this. It will cover it like this here, here. Okay, so let's see. So what happens now? If the ray is passing through here, it will pass undeviated, right? Now, if the ray goes here, this is normal. It will bend towards normal. Now this is normal. It will bend away from the normal like this, right? Now if the ray goes here, this is normal. It will bend towards normal. Now this will be normal. It will bend away from the normal. See, the rays are diverging. In this, the ray will converging. Here the rays are diverging. So this is known as converging lens. This will be known as a diverging lens. Okay, next, divergent. See, The prism in the upper part of the concave lens bends the incident ray A upwards, that is towards its base, while the prism in the lower part of concave lens bends the incident ray C downwards, that is towards its base. The central part will be undeviated, will pass undeviated. Okay. Next, technical terms related to lens. What are the technical terms related to lens? Like we studied terms related to spherical mirrors, right? Here we have to study related to what? Lens. See, this line is known as principal axis, we know that. And the center of, see, we have two different types of spherical surfaces, 1 and 2. Okay, 1 and 2. So this will be center 1, because this is first one. This will be center of first one, and this is second one. So this will be center of second one. Okay. So C1 and C2 are center of curvatures. C1 and C2 are center of curvatures. Okay. Okay, done. Now the distance from here to here will be R1, here to here will be R2. Those are radius of curvatures. Similarly here as well, see, C1 and C2 will be center of curvatures, and the distance will be R1 and R2, radius of curvatures. Okay. This central part of lens is known as O. O is optic center. O is what? Optic center in both of them. Okay. Just a difference is what? In convex lens, C1 will be here, C2 will be here. C1 will be right side, C2 will be left side. But in concave lens, C1 will be left and C2 will be right. That you need to remember. Okay. Next, principal focus. What is principal focus? Just a minute. What is principal focus? A light ray can enter a lens from either side. Therefore, a lens has two principal foci. You have two principal focus. If the medium is seen on the either side of the lens, the two foci are situated at equal distance from the optic center, one on the either side of the lens. These are known as first focal point f1 and second focal point f2. Let us see what is that. See, this is a lens. Okay. Light can enter. This is principal axis, right? This is principal axis. If sorry, see, if light enters like this, it will bend here, right? You know about concave lens. If light enters like this, it will bend here. This will meet at some point known as focus. Known as what? Focus. So this is the first focus point, f1. This is first focus point, f1. Now if the rays come from here, this way, like this, so they will meet some point here at this point. This is known as f2, second focus point. Okay, second focus point. See, here it was f1, and if they come from this side, if they are coming from this side like this, they'll again bend right towards here. This is f2, second focus point. Now the distance from optic center to first focal point is known as focal length 1, first focal length, and this plane will be known as first focal plane, where the first focal length is present. Next, the distance from optic center to f2 will be second focal length, and this plane will be known as second focal point. So we can draw for concave lens as well. See, the rays will diverge here, right? It will get diverged, and if we trace back, it will meet at this point known as f1. So here it is f1 for this, right? You know that for this we have seen for concave C1 C2, for convex C1 C2, like that. Similarly f1 f2, for this f1 here, f2 will be here, see, like this, in this way. The rays are coming from here, it will go deviated like this. So if it retrace back, it will meet at some point known as f2. Okay, every lens will have two focal points, that is f1 and f2. For concave lens, sorry, convex lens, it will be right side will be f1, left will be f2. For convex lens, concave lens, left side will be f1, right side will be f2. Okay. Next, focal plane. We have studied the plane normal to the principal axis passing through the focus is called a focal plane. It has two focal plane, first and second. A plane passing through first focal point is called first focal plane. Second focal point will be called second focal plane. Similarly, we have two focal lengths. The distance of focus from optic center is called focal length. So the distance of optic center from first focal length, first principal focus, that is nothing but first focal point will be focal length 1 to second focal point will be focal length 2. We have two focus f1 and f2, so two planes f1 and f2, so two focal lengths as well, small f1 and small f2. Simple. Next, note point you need to remember. If the medium on both sides of a lens is same, its first and second focal lengths are equal. This f1 will be equal to f2. If see here, there is a lens here, right? Here there will be some medium, here there will be some medium. If both the mediums are same, then focal length, distance of both the focal length will be same. F1 will be equal to f2. They will be having equal focal lengths. The focal length of lens usually means its second focal length. Remember, this is point to be noted. Point to be noted. Focal length of lens means its second focal length. See, its second focal length. Its second focal length. Okay. A convex lens has a real focus, but parallel rays actually pass through the focus after refraction. See, in convex, there is a real focus, right? Because they are actually passing through this point. So we have real focus. Here we will have virtual focus because these rays are appears to meet, right? We have studied real image and virtual image. Okay. A concave lens has virtual focus because parallel rays only appear to diverge. Next. Only rays parallel to the principal axis converge at the principal focus. This we'll study in the next part. Which rays will converge to principal focus or diverge to principal focus. Okay, in next lecture we'll be studying that. Obliquely incident parallel rays converge in the focal plane, not at the focus. They can converge at focal plane, the whole plane, but not at focus. Obliquely incident ray. Obliquely means in 2D surface. Like if the lens is this, they are coming like this. In this way, if they are coming, they can meet at in this focal plane where f is present. There they can meet, but not at focus, not at that point. In that plane, they can meet anywhere. This is a plane, right? This is completely split. This is focus point, so they can meet here, wherever, but not at focus. Okay. Next. The focal length of lens depends on refractive index of lens and radius of curvature. These two things, it depends on refractive index and radius of curvature. A thicker lens has a smaller focal length than a thinner lens of the same material. Thicker length will have smaller focal length. Why? Because thicker length radius will be less. That's why. Thicker lens will have smaller focal length, but thinner lens will have larger focal length of the same material, if they are of same material, because it depends on material, right? Next, covering a part of lens does not change its focal length. Covering a part of lens does not change its focal length. Only brightness of the image decreases. Its position, size and nature remains same. If we cover any part of the lens, the focal length won't change, the color, position won't change, size won't change and nature won't change. Just the brightness, intensity decreases. Okay. Next. Difference between convex lens and concave lens. What are the difference? Let's see. It is thick in the middle and thin at its periphery, but it is thin in the middle and thick at its periphery. It converges the incident ray, but it diverges the incident ray away from principal axis. It has a real focus, it has a virtual focus. Any 2 or 3 you need to remember. Next, refraction of light through equiconvex and equiconcave lens. Equi means equal, both will be equal. A convex lens converges light towards its center, while a concave lens diverges light towards its edge. In both cases, light went towards the thicker part of the lens. It went towards the thicker part of the lens, towards this part. See, here we have bent. See, it's bending towards thicker. It's bending towards thicker. Here, towards thicker. Thicker is at periphery, right? So it will always bend towards thicker. Remember that. Either it be concave or convex, it will bend towards thicker. Next, PYQs. First question: in which of the following diagrams is a refraction not correct? Let us see. This we can do in second lecture. Why? Because we haven't studied about array diagrams, right? But the answer will be, wait, let's see. See, if it passes through focus, then it will go through parallel axis. So this is wrong, not correct, right? B, if it passes through focus, it will go in a straight line. This is also wrong. Two options are wrong. C, this is correct. And if pass through optic center, it will go undivided. This is also correct. These two are wrong. This is not correct. More than one can also be answered, right? This is not correct. Next, why is a convex lens called a converging lens? Why is it a converging lens? Because you can write it down, right? When the parallel beam of light rays falls on the lens, it converges the rays at a point called principal focus. That's why it's called as converging lens, right? Define principal focus of a convex lens. The principal focus is a point where the parallel rays of light comes and meets after refraction. So we can say this as well. Next, state two differences between convex and concave lens. What are the differences? First differences will be convex lens is thick at the middle, thin at the periphery. But concave will be thin at the middle, thick at the periphery. Convex has real focus, concave has virtual focus. Right? Only two. It required. We have given two differences between convex and concave lens. Done. So with this, the first lecture, that is nothing but part A, is completed. Too easy, just types of lens we have studied, convex and concave lens. In next part, we'll be studying about how is the image formed by convex and concave lens. Okay. Till then, keep reading, keep supporting. Download the Easy Notes app. Bye bye.